Hello everyone. So today we're going to be looking at three integrals and we're going to find the value of each using geometry. Now certainly, for example, for b you can use the fundamental theorem of calculus to compute it, and it's okay, I would say, to compute. But in some cases, like C, for example, geometry is a lot easier because you can forego some computational techniques. Can be kind of or somewhat long here. So go ahead and get started. I'm going to go ahead and start with A here. Now, when you're using geometry to find the value of an integral, what you want to do is you want to go ahead and graph the integrand. So I'm going to graph the absolute value of 2x minus 1, which is that shape that you see there that looks like a V. And we'll go ahead and look at the relationship between that graph and the x-axis. Let me just label the x-axis and the y-axis. The reason for that is what an integral is computing. It's computing the net area between a graph and the x-axis. And what I see here is that I see two triangles that are formed. Okay. One triangle, the one that goes from 1/2 to 4, and the other one that goes from -5 to 1/2. And well, we know how to find the area of a triangle. It's 1/2 the base times the height. So let's go ahead and try to do that here. For my first triangle, the one that goes between 1/2 and 4, the length is, or the length of the base is 3.5, or 7/2 if you prefer. And for the height, well, what you can do for the height, it's that red line that you see there that's over the 4. You can plug 4 into your function, 2 times 4 minus 1, so that'd be 7. So the area would be 1/2 times 7/2 times 7, which would be 49/4, which would be like 12 1/4 around there, if I'm not mistaken. But I'll just keep it like that. I'll keep it exact. And I'm going to do the same thing for my next triangle. The one that goes from -5 to 1/2, that has a length of 5.5 units, which is 11/2. And the height, if you plug -5 in, comes out to be 11. It just 2 times -5 minus 1 is a -11. The absolute value of -11 is 11. So the area here would be 1/2 times 11 times 11/2, and that comes out to be 121/4. So your final answer here would be, we call this A1 and A2. A1 plus A2, 121/4 plus 49/4. And that looks like that'll give me a 170/4. Okay. And I mean, yeah, for me, that's good enough. If you want to, convert it to a mixed fraction or a decimal, by all means, go right ahead, but I'm just going to leave it like that. All right, and then we'll go to the next graph here, the next integral, and the next graph. 4x plus 1 is what we're going to be considering for the integral that goes from 0 to 5 of 4x plus 1. So 4x plus 1 is just a straightforward line, as you see there. And the shape that we're looking at in terms of like the area, again, we're looking at the area between the x-axis and the graph between 0 and 5. This time is going to be a trapezoid. And a trapezoid has an area of 1/2 height times base 1 plus base 2. Or sometimes it's written as 1/2 base times height 1 plus height 2. It's up to you how you want to write it. In this case, I'm going to use this one because it seems like you have two heights here. And then you have one base. So the base is 5 units long. That's what this would be here. This would be 5. So 1/2 times 5. And then for my heights, you get your heights when you plug 5 into your function and then 0 into your function. This would be 21 because 4 times 5 plus 1 would be 21. And then 4 times 0 plus 1 is 1. So you have a height of 21, a height of 1. And therefore, your area would be total 1/2 5 of 22. So that's 55 total. That would be your area, 55 units. Okay. Now for last but not least, see here. C was the integral from 0 to 3 of the square root of 9 minus x squared dx. Now this graph might be a little harder to interpret, so what I'm going to do is following. I'm going to call this, it's technically an f of x, but I'm going to call it y here, because we tend to relate y and x better on like an axis. And I'm going to square both sides, so you'll get y squared equals 9 minus x squared, or x squared plus y squared is 9. So I move that x squared over, so we can see what this equation gives us. It's more recognizable that way. And that is basically an equation of a circle. Okay, so you are looking at, for our problem, not a whole circle, but part of one. We'll get to that in a minute. But yeah, that's the circle, and it goes out 3 units because the radius is 3, square root of 9, 3. So 3 units this way, 3 units that way, 3 units this way, and 3 units that way. And this is actually minus 3 and minus 3 here. Okay, well, here's what we're really looking at though. Y equals the square root of 9 minus x squared is what I started off with. That really is the top half of this circle. So it's all that you see here. Okay. But furthermore, the limits of integration go from 0 to 3. So that means that you're really looking at this quarter of a circle. Okay. So our area would be the area of a quarter circle. So the area of a regular circle is pi r squared, but because it's a quarter of a circle, it's going to be divided by 4. And we know what the radius is. The radius in this case is 3. So 3 squared. So you would get 9 pi over 4 total. So that would be the value of the integral, because it's representing that area. Okay. So this is a very useful technique. It works out really well when you have things of the nature with square roots and like absolute values. But as you can see, it was, in my opinion, it was okay to use also with that 4x plus 1 function. All right, well, thank you for your time.